Well, really happy to be here. That's for me first time being actually in Paris. I only been to Disneyland Paris before, but not in Paris city. So it's really nice to be here and at this conference. So today we'll be talking about some practical steps to level up your MLOps and LLMOps maturity, or LLMOps. I'm not sure about this term anymore. Agentops might be a better one. But yeah, you know what I'm talking about. So yeah, as I was introduced, I am in data and AI already for 12 years. Time goes fast. In MLOps for 9 years. And I started my career as a data analyst, moved into doing data science, then led teams, was engineering manager. Now I co-founded Koshi, which is a consulting company focusing on agentic data platforms. So I consult and educate on MLOps, and I love, well, beside my cat, I like coffee and yoga. I'm actually doing yoga teacher training, so my dream is to run maybe some yoga retreats for data people. That would be awesome. So MLOps is a paradigm that aims to deploy machine learning models and AI agents to production efficiently and reliably. But what is actually production? Production means simply that the output of an ML model or an agent or a workflow is consistently delivered to the end user and delivers value. Well, until now, I think ML use cases were really dominating and actually were bringing value, but now you see a lot of agentic use cases coming there, and you see first value being delivered inside corporate organizations everywhere. This is a database of all agentic and ML use cases by Evidently AI. I really like that overview. You should check that out. Basically, it's an overview of all kinds of use cases within different industries and how people solve different problems that they have. In this overview, most of the use cases now are agentic. It's all generative AI and LLM, and that has not been like that even a year before. So we see this dominance is just there today. And there is another overview, LLMOps database by ZenML, where you can find also different agentic use cases. So we see a lot of value these days in Gen AI. And we see internal and external use cases. Internal ones are for productivity. People claim that they can do large-scale migrations much faster, like from 1.5 years to a couple of months. Application testing, application performance improvements, internal ticket handling. Also for customer service, that's something that was NLP-driven already for a very long time. And finally, we see the huge improvements in that area. And there are also external use cases like chatbots, recommender system, and search, or some kind of combination of those. There is a diagram from Chip Huyen Book's book, AI Engineering, amazing book, everyone should read it. According to her research, internal-facing applications are more likely to move to production than external-facing applications because, well, deploying AI application is just hard. There are just so many different components moving there, and it must be reliable. And, well, reliability is an issue. So let's say we have a use case like that, like grocery retailer recipe recommender. I work for a grocery retailer, and we have such a use case. So the idea is to integrate the recommender in the existing chatbot to recommend recipes from the knowledge base based on the customer query, and also find relevant products from the product database so that those can be added to the basket. So the whole idea behind that is actually make the journey of finding products easier for people and also, of course, increase the value of the basket. So let's say a product manager would go to AI engineer and ask him to create a POC. And what they could do in such a scenario, go and create a Databricks notebook where you could deploy an agent behind a serving endpoint. And it can be all one notebook. Well, you can do that. Technically, it's production if it's integrated within your systems. Is it efficient? Well, maybe. I guess it's better to deploy it in a notebook like that in actual system than maybe from your machine. Is it reliable? No. There are so many things wrong about it, and we're going to talk about how to make it better. Well, yeah, something is missing. So first of all, version control everything and connect the dots. It may be obvious for everyone that we need to have code version control, but not everyone is still doing that. So the idea is that when you have an ML model or an AI agent running in production, you need to know what code it came from, what data was used to create maybe prompts or to run evaluation, and what environment was used to build the agent itself, and what prompts were used. So if we are looking at such a setup, how would it work? So here is an example of a PDF processing setup and use case. So let's say we have some PDFs that we need to process. We could use AI parse document from Databricks to create parse document delta table where we have all these documents in one place. And then we could create a vector search index. That is also defined as a managed MCP within Databricks. So it has different tools available for your agents, such as finding the most similar documents. And those PDFs can also be processed, and metadata of those PDFs can be stored in Delta table as well. And you could create a Genie space, which is also an agent managed by Databricks that has access to this data in the tables. And here it's a very simple example of an agent. It's actually a pretty dummy agent. It only can choose tools and then act accordingly. And it's kind of a for loop. But more complex agents can have more logic built into it. So the idea is that the agent, to deploy it, you actually have to log it and register it Unity catalog. And there are different pieces that you must log together with your model so that you actually know how that model was created. So the evaluation input data, evaluation metrics, then the versions of those delta tables, and you could tag it with code version and some deployment identifier. So what kind of run, where that exactly came from. Well, I have a little code snippet here, so how I typically do it, you could tag your your run with git sha, which is the identifier of your code, and run ID from Databricks. And you could also log input of your evaluation data. So why is logging input important? Because the data may change over time. The table may change over time, and you need to get the exact version of that data that was used to run evaluation. Because if it just changed, your evaluation metrics may change as well. And if you log parameters and metrics accordingly, then you just don't know where that is coming from. And also, in that way, we can always evaluate different agents, if we, let's say, change it, according to the same evaluation set. Databricks allows to already package environment together with a model. And you have this definition of a ML model that encapsulates everything that we know about the model itself. So it says what client was used to log the model, what Python version was used, and all the details about different paths. So basically, it encapsulates the whole environment within the model, and that allows to deploy an endpoint on Databricks with all the dependencies that we need and make sure that it runs exactly the same way. Well, there are different ways to actually check whether that's the case before you deploy the model, but we are not going to go into those details. The second point, after we need to version control everything, we need to trace the agent logic. And MLflow also has MLflow tracing, which helps us to understand what's going on within the system. So what steps the agent has followed, what was the tool usage, what was the input and output, tokens used at each step, and number of tool calling and total number of steps. So let's say if on average we have, I don't know, 5 tool calling to come up with certain response. And this time we have 20, we want to know and react on it on time. MLflow tracing can help you do that. You could also, in MLflow tracing, you could specify different outputs that you could, for example, output in open telemetry for actual real-time handling. So here is in the screenshot, you can see for a certain query, you have those steps that were running within the agent. And you can deep dive into those. So this was a LLM call with those inputs and those outputs, and these outputs are really big. So you also know how many tokens were used and, well, everything you need to know really about it. And what's nice about it is that it also can be stored in a delta table and analyzed later. To enable MLflow tracing, it's actually very simple. If you remove this red buckets, you will basically have no tracing. And you can simply add it by having decorators in MLflow trace in different steps. And it's a very easy thing to do, and I think everyone can do it. So the next step after tracing is importance of human in the loop. So within the tracing interface, we know what was going on at each step of the agent, but we don't know whether that action was correct. So what we could do, there is an interface within MLflow that allows a human or another or an LLM to evaluate each of these steps. So in this case here, it's actually not human, it's GPT-4.1 Mini that makes the evaluation, but also a human can log in into the interface and actually give the feedback. And all of that will be recorded for each trace, for each step, and you know what to do, and you know how to use it later. And those things are tied into different assessments. We will talk evaluation in a minute, but basically you can specify what you are scoring against, and there are different scores available within Databricks, or you could create a custom one that allows you to have this kind of overview because of the human input or an LLM input. So the evaluation step by step includes the following actions. First, you need to generate traces or collect them from production. So traces you could already have on the development stage, in fact. So I could log MLflow agent from my machine, and it would still be all there. And already at this stage, I could go on and give feedback, which can be used later for production stage. Then we need to gather human feedback. It can be done via UI. You could create a separate interface because, in fact, it's just an API call. And there you can do error analysis. So you know where the agent made mistakes. You could say this is the common value model, and you want to act upon it. So you can create a scorer based on that, and that allows us to create a custom judge aligned with a human feedback. So within MLflow, you have different types of approaches with a minimal to full level of customization. So you have built-in judges with minimal level of customization, like correctness, fairness, groundness, and I think they have like 12 different evaluators, and you can define what model is used to run it. There are different guidelines judges where you in just English can say what are the guidelines for this judge. Well, and that's what it is, pretty much like if you were using yourself ChatGPT to evaluate certain input, and custom judges where you can define this kind of scores based on the value models that you have seen. And this can be all written as code, not just via UI, and that's where we want to get eventually, to have that incorporated in the whole process. Which leads us to introduction of monitoring. Monitoring is a big problem in MLOps and LLMOps, and it's not solved. We are getting closer to solving it, though, because it gets more attention today. But but still most of the companies don't have any monitoring in place. So this is the state of ML in 2025. It's a survey chart done by Ethical Institute of AI. They make this kind of overview last 2 years. Previous year, this number was even higher. So monitoring is just a really missing piece, and we need to pay more attention to it. What do you monitor, though? There is generic monitoring, things like system health, error latency, AI-specific monitoring, like data quality checks, application-relevant evaluation metrics, such as correctness, safety, instruction following, and cost to business value. So infrastructure costs and the breakdown of the cost based on, well, who called the agent, who used the agent, and eventually business value. That's what we want to know. We want to know whether without or with the agent, well, we're actually getting something from it. So how you could do monitoring? That's an extra step that we need to introduce. So from MLflow tracing, as I mentioned, we can gather human feedback and the tracing table. So basically all the information from the tracing can be stored in Delta tables. There is a concept of inference tables on Databricks that allows to log all the input and output of the agents and foundation models. And all of them, if we combine, we have a lot of knowledge which you could use to create dashboards and custom alerting. And that's, for me, a part of monitoring that is essential and possible already today on Databricks. Another step is controlled deployment. So again, coming back to this survey, most companies don't deploy ML models or AI agents properly. Only 32% actually do CI/CD for continuous deployment. Which makes me think, well, everyone is probably doing it through notebooks. The same goes for development stage and production environment, only 25% does it. So we are in a very immature state when it comes to MLOps, and there is a lot to win here. So how you would do such a thing? I could talk hours about it, but just to make it a bit shorter, we could have a deployment pipeline within MLflow. It has MLflow deployment jobs, which allows us to only deploy things to production, which already follow evaluation, human approval, and deployment. There is nothing about CI/CD pipelines here yet, but each of these blue pieces can be deployed as an asset bundle resource. I don't know whether you're familiar with the asset bundles in Databricks, but it basically is a YAML definition of all the resources that is version controlled and is part of your CD pipelines. So you can simply deploy all the resources using a Databricks bundle deploy command. And well, just to describe it shortly, you could already experiment with this deployment from your development, local development environment and deploy it to production, to development environment on Databricks, but you also can deploy it to staging and production environment in a controlled way through CI/CD. So typically, you would follow similar like that branching strategy and deployment strategy that you create a feature branch, you work on it, then you create pull requests to the main branch, and at the pull request, the tests are running and manual approval is required to actually merge to main, and once that's done, the deployment can run to production and acceptance. So you have multiple kind of controlled deployment steps through CI/CD pipelines plus through the MLflow deployment jobs. And the last piece, which I'm going to run very fast through, the documentation is your competitive advantage. So before, documentation was perceived as boring. Documentation was an afterthought. But today, we see it as something that makes your life so much easier. AI context documentation allows to develop with AI efficiently, and it is version controlled. And it allows both AI and human understand the system better. And it makes such a huge difference. If you ever tried using Claude Code or similar tools, you know how much difference it makes. I will not go through how to structure your documentation, but this is a nice, amazing resource from Anthropic, best practices for agentic coding. And there is also a deep learning AI course, multiple actually by Anthropic, that tell you exactly about it. So we went through 7 different steps. And the last thing what I want to say, deploying ML models in AI agent is easy if you ignore all the hard parts. And it seems like almost everyone is ignoring all of these hard parts that I was talking about. Well, thank you so much for your attention. This is the book that is coming up in May. And you can follow me on LinkedIn and ask me questions there as well. Thank you so much.